Hi, welcome to my channel. In this video, we want to solve the following problem. Lines L1 and L2 are common external tangents to three circles, touching the circles at A, B, C and P, Q, R respectively. The large and medium circles are tangent externally at M, while the medium and small circles are tangent externally at N. A third line L3 is tangent to the large and medium circles at M, intersecting L1 at W and intersecting L2 at X. A fourth line L4 is tangent to the medium and small circles at N, intersecting L1 at Y and intersecting L2 at Z. Given that O1M O2 NO3 is a straight line, Wx equals 16 square root 3 units, and yz equals 12 square root 3 units. The goal is to find the radii of the three circles. And now for the solution. First, let us call the radius of the large circle as R1, the radius of the medium circle as R2, the radius of the small circle as R3, and then consider this part of the diagram. Recall that if lines L1 and L2 are common external tangents to two circles with centers O and M, then L1 and L2 are symmetric with respect to OM. Since PQ and AB are common external tangents to the large and medium circles, they are symmetric about O1, O2. Therefore, by symmetry we have MX equals WM. Next, recall that if PA and PB are tangents from P to a circle, then we have PA equals PB. Since WA and WM are tangents from W to the large circle, we have WA equals WM. Similarly, WB and WM are tangents from W to the medium circle, thus we have WB equals WM. Since Wx equals Wm plus Mx, which equals Wm plus Wm, which in turn equals Wa plus Wb, we have Ws equals Ab. Next, connect O1 to A and connect O2 to B. Recall that if AB is tangent to a circle with center O, then angle OAB is a right angle. Since AB is tangent to the large and medium circles, angle O1AB and angle O2BA are both right angles. Following this, from O2, draw a line perpendicular to O1A, cutting O1A at D. Then ABO2D is a rectangle. Since the sides of a rectangle are equal, we have AB equals O2D and DA equals O2B. The length of DA thus equals R2, and so the length of O1D equals R1 minus R2, while the length of O1O2 equals R1 plus R2. Next, consider triangle O1DO2. By Pythagoras theorem, we have R1 plus R2 whole square equals R1 minus R2 whole square plus O2D square. After expanding the brackets, we observe that R1 square plus R2 square cancels out, giving us O2D square equals 4R1R2. Taking the square root, we obtain O2D equals 2 square root R1R2. Since Wx equals O2D, we have Wx equals 2 square root R1R2. By similar arguments for the medium and small circles, we can show that yz equals 2 square root R2 R3. Next, connect O3 to C. Since BC is tangent to the small circle, angle O3CB is a right angle. Then, from O3, draw a line perpendicular to O2B, cutting O2B at E. Therefore, EBCO3 is a rectangle. The length of EB thus equals R3, and so the length of O2E equals R2 minus R3, while the length of O2, O3 equals R2 plus R3. Following this, consider triangles O1D02 and O2EO3. Let us show that these triangles are similar. Since O1D is parallel to O2E, angle O2O1D equals angle O3O2E. Furthermore, angle O1DO2 equals angle O2EO3 equals 90 degrees. Therefore, by the AA similarity criterion, the two triangles are similar. Since corresponding sides in similar triangles are proportional, we have O1D over O2E equals O2O1 over O3O2, or R1 minus R2 over R2 minus R3 equals R1 plus R2 over R2 plus R3. Cross multiplying gives us R1 minus R2 times R2 plus R3 equals R1 plus R2 times R2 minus R3. After expanding the brackets, we observe that R1, R2, and R2, R3 cancels out, and we obtain 2R2 squared equals 2R1, R3, or R2 squared equals R1, R3. Taking the square root, we obtain R2 equals square root R1, R3. Multiplying these two equations gives us yz times wx equals 2 square root R2, R3 times 2 square root R1, R2. We then write the right hand side as 4 square root R1, R3 times R2. Using R2 equals square root R1, R3, Wx equals 16 square root 3, and Yz equals 12 square root 3, we obtain 16 square root 3 times 12 square root 3 equals 4R2 times R2, which simplifies to R2 squared equals 144. Taking the square root, we obtain R2 equals 12. From the equation for Yz, we have 12 square root 3 equals 2 square root 12 R3, which simplifies to square root R3 equals 3. Squaring both sides gives us R3 equals 9. Similarly, from the equation for Wx, we have 16 square root 3 equals 2 square root 12 R1, which simplifies to square root R1 equals 4. Squaring both sides then gives us R1 equals 16. Therefore, R1 equals 16, R2 equals 12, and R3 equals 9 is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.